Hello students, welcome to Vassiversity. This playlist is going to be on college algebra for University of California, and today we're going to be covering real numbers and their properties. Alright, so let's start with real numbers. What are real numbers? And we're going to be covering the material specifically designed for University of California from the book College Algebra by Ron Larson. And to be specific, let me write down Ron Larson and 11th edition. Right, perfect. So, real numbers. What can be real numbers? And real numbers can describe the quantities in everyday life, such as age, miles per gallon, and population. And what would be the example of real numbers? -3, -2, 0, 5, 4/3, 0.555, pi, etc. Right, all of those numbers are real numbers. And there's a commonly used subset, right? So what is a subset? Right, subset of real numbers is essentially a group of some kind of numbers, a certain group of numbers. So an example would be, so let's take a look at group 1. Group 1 would be 1, 2, 3, ... 10, 1,000, etc. Right, those kind of numbers we call set of natural numbers. So this is natural numbers. Okay, then the second kind are going to be set of whole numbers. Right, the whole numbers are including 0, 1, 2, ... 10, 1,000, etc. Okay, so this is whole numbers. And one of the also very popular subsets would be the subset of integers. So we can start -10, -9, ... 1, 0, 1, 2, ... 10, etc. Okay, that we call them integers. Alright, so what else we have for the subsets? Besides that, we can also have rationals, right? This is less common ones, but also used in mathematics. So we're going to have rationals. Rationals are actually the rations. So you probably have seen some of them. 1/3, which is 0.33 repeating. And 2, 6 would be the same thing as 1/3, right? Because we can simplify stuff. And then we can have 1/8, which is 0.125. Exactly. And 0.125 is also a rational number because it can be viewed as a fraction. In addition to that, we can also have irrational numbers. So irrational numbers. That would be square root of 2. Or pi, which is equal to 3.1415926, etc. Right, or sometimes we can approximate it as 3.14. Right, but we cannot express it as a fraction, so that's why it's irrational. Okay, so let's take a look at an example. We would have a set of numbers. Right, and we can classify them. So for natural numbers, right, what are we going to have here? We're going to have 7. 7 is the only natural number here. Then how about integers? So here we're going to have -13, -1, 0, and 7. -13, -1, 0, and 7 once again. Okay, how about irrational numbers? So irrational numbers are going to be here. Negative square root of 5, square root of 2, pi. And then whole numbers. What would be whole numbers? here we're going to have 0 and 7, right? 0 and 7. And the last one's going to be the rational numbers, right? Rational numbers are all of the numbers that can be viewed as a fraction, right? So rational numbers are negative. So we can say negative 13, negative 1, negative 1/3, 0, 5/8, and 7. Right, negative 13, negative 1, and 7 can be viewed as a fraction, right? Because we can say negative 13 over 1, or negative 26/2. That's a fraction, right? Perfect. So we know how to classify. So now we know how to classify properly the real numbers and what kind of real numbers we have. But in addition to that, we can also plot the numbers on the number line. So let's go ahead and take a look at it. You can draw a number line. Very common concept in algebra, right? How we can distinguish the numbers. So let's take a look at it. So the very center of the number line is going to be 0. So on the right side are going to be positive numbers. So positive numbers, right? And on the left side, we're going to have negative numbers. So negative means they are less than 0. So what would be an example? So here we have 1, 2, ... Here we have 10, etc. And on the left side, we would have 1. So it would be negative 1, negative 2, ... negative 10, etc. Okay, so if we go really high into the numbers, the number is going to be increasing. They are going to approach positive infinity. So here we can think of it as positive infinity. It's going to be a symbol here, right? Not actually a number, but a symbol that means that the number is very large. And on the left side, we would approach negative infinity, right? And for example, between 1 and 0, we have an infinite amount of numbers, because we can have all of the fractions between negative 1 and 0, all of the decimals, all of the irrationals, all of the rationals, all of the numbers between them. Okay, so for example, that would be the way we would essentially plot the points and order the real numbers. So we know that the more we go on the right, the bigger we get. The more we go on the left, the smaller we get. So we know that negative 2 is actually smaller than negative 1, right? And for example, negative 4/3, right, is going to be smaller than negative 1/2 for the negative scale. But for the positive scale, we will have that 2 is actually greater than 1, and 4/3 is also greater than 1/2. Okay, so it's always useful to draw the number line before deciding what kind of point we have and what kind of number is actually bigger or smaller to another number. Okay, and of course, we can also have intervals. Right, intervals would be a specifically designed breaking points for the number line. Right, as an example, if I mirror this number line, the number line, and I'm going to say that I only want to be restricted between negative 2 and 3. So here we have 2, here we have 1. I'm going to change color here, so it's 1 and 2, 3. So I want to restrict between negative 2 and 3, right? But I want to say, so my interval without including the points. So if I don't want to include them, instead of a dot, I would put an empty dot. So that kind of an interval would be negative 2 to 3 with parentheses. So parentheses means the numbers are not included. Okay, and then for example, I'm gonna say 2, negative 2, and 3, not included. And how about this line? So if I do 0, negative 2, negative 1, 1, 2, and 3, 1, 2, and 3. So if I do open dot, close dot, that means my interval is going to be from negative 2 to 3 with a bracket. Means that 3 is included. 2 is not. Negative 2. Okay? And then, of course, we can do it from both sides. And for both sides, it will be both of them included. So you can have -1, -2, 1, 2, 3. So if I color the dot from both sides, I'm going to say that my interval is bracket from -2, comma 3. Right, so we're going -2, and everything between -2 and 3 are going to be in that interval. And of course, if we are dealing with an infinite interval, for example, we want to say all of the positive numbers, anything that's greater than 0. Right, how would we display that on the number line? We would do it the following way. So we would have, let's say, a 0, 1, 2, dot, dot, dot. Here we would have positive infinity. Right, so what do we want to do? We want to include everything from 0 to positive infinity. So we would do it the following way. It would be, let's say we want to include 0. Right, so it's going to be from 0, which is a bracket, to positive infinity. And infinities are always going to be in parentheses. Okay, so both positive or negative infinities, doesn't matter, we're always going to be in parentheses. We're never going to put a bracket. The infinity is never included. Okay, and the last topic that we're going to be defining today is the absolute value of the number. So what is an absolute value of a number? So an absolute value of a number, let's say we're written as this, so of a, absolute value of a. So it's going to be a if a is greater or equal to 0, and it's going to be negative a if a is less than 0. Okay, so, and the properties of absolute value. The properties of absolute value would be, so property number 1, absolute value of a is always greater or equal to 0. Property 2, absolute value of negative a is also is equal to a. Absolute value of a, and also greater or equal to 0. Property number 3, we're going to have a times b, absolute value is the same thing as absolute value of a times the absolute value of b. And the last property is the absolute value of a over b is going to be absolute value of a over absolute value of b as long as b is not equal to 0. Okay, so what would be an example of such? So we can think about example 2. So absolute value of -1.5, that's going to be just 1.5. Okay, absolute value of -3 over 4 would be absolute value of 3 over 4, which would be absolute value of 3 over absolute value of 4. Since both of them are positive, it would be just 3 over 4. Right. Perfect. So, that would be it for today's lesson. And thank you very much, and I'll see you all in the next lesson.